Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Hello, ladies and gentlemen. This is Mr. Whitt with Fort Bend Tutoring, and today's tutorial is going to be about systems of exponential equations. So let's check it out. Yeah, we're going to start out with a snapshot. A snapshot of the first few problems that I'm going to have in this video today. Okay, so here's number one. Yeah, there you go. Number two. Number three. Yes, and number four. So here are four of the problems that are going to be done in this video in front of your face right now, but there are 10 altogether. Yeah, I have 10 problems. Yeah, we're going to have fun today. All right, so let's get started. Let's get started. So what I have prepared for you before we begin is just a recap on some of the exponential rules. Go ahead and absorb this, take this in. Go ahead and get used to that. Yeah. So for instance, if we have let A, M, and N be a member of the real number set and A cannot equal to 0, then these rules will apply. There you go. There you go. They're all right there. Gotcha. We'll be using some of these. I like this one right here. Yeah, that's a good one. The quotient rule for exponents. Yeah, same base, dividing. You're going to subtract the exponents. Yeah. Here's a good one over here. Yeah. A to the 0 power. All right. If A is not equal to 0, that the result will be equal to 1. That's always refreshing. Yeah. Then here's this one. There you go. A to the m power times A to the n power equals to A to the sum of m and n. I utilize all of these rules in the video that's right here, the integers as exponents video, if you want to recap on some of those things. Let's get started. Thank you. I appreciate it. Let's just go ahead and get started. I'm glad that you were waiting patiently for problem number one. We have y equals 5 to the x power and y equals 5 to the 2x minus 1. And lo and behold, I believe in order to solve this equation here, I will be setting these equations equal to one another because look, y equals 5 to the x, but it also equals 5 to the 2x minus 1. So since y must equal to y, let's set this equal to one another. And just for clarity, ladies and gentlemen, you should know that we're looking for the potential intersection of these two exponential functions. So in other words, these two intersecting functions will meet at a point. Yeah, so we need an x and a y value to describe the point of intersection of these two exponential functions. And let's get started. So I'll begin by setting these two equations equal to each other, and I'll have 5 to the x must equal 5 to the 2x minus 1. Oh, yeah. And then I'm going to go ahead and set this equal to 0 by subtracting 5 to the x to both sides of the equation. Thank you. I'll end up with 5 to the 2x. Minus 5 to the x minus 1 equals 0. Yeah. Now, one thing I do know, and you should recognize as well, is that anytime the middle term's exponent is half of the first term's exponent, then the equation will function in a quadratic manner. It'll act as though it's a quadratic equation. So let's do some substitution. I'm going to say that u equals 5 to the x. And if u equals 5 to the x, then u squared must equal 5 to the 2x. Yeah. So using u and u squared to substitute into this equation right here, I can rewrite the equation as u squared minus u minus 1 equals 0. And from this point, we have a quadratic equation that we can solve. Now, this equation is not factorable. Unfortunately, it's not. I kind of wish it was, because that means we're going to have to use either completeness square or the quadratic formula in order to solve this. We'll have a equals 1, b equals -1, and c equals -1 as well. And we'll be plugging these values into the quadratic equation. And as a reminder, our quadratic formula is u would equal to -b plus or minus the square root of b squared minus 4ac, that's a 4, thank you, divided by 2a. And we'll be plugging in those values, right? So we know that plugging this in, that I'll have -1 plus or minus the square root of -1 squared minus 4 times 1 times -1. All right. And all of this, of course, is going to be over 2 times 1. Yeah. So then from here, we'll just go ahead and simplify this. So simplifying this, I know that the opposite of -1 is +1. That'll be 1 plus or minus the square root of 1 plus 4. The result of -4 times 1 times -1 is +4. All right. I know you knew that. I know you knew that. And then this is going to all be over 2, the product of 2 times 1. Yeah. From here, let's go ahead and combine those like terms underneath the radical symbol there. And we'll have 1 plus or minus the square root of 5 divided by 2, which means that our potential values for u will be either 1 minus the square root of 5 divided by 2 or 1 plus the square root of 5 divided by 2. All right. And remember, this all is equivalent to u. Keeping in mind that u is equivalent to 5 to the x, if I replace one of the values that we just found for u into this equation, we would have 1 minus the square root of 5 divided by 2 equals 5 to the x. Let's start by taking the natural log of both sides. So we'll have the natural log of 1 minus the square root of 5 divided by 2. And we'll also take the natural log of 5 to the x. Well, for starters, I already know that this won't work, okay? And the reason why this won't work is because I can't take the natural log of a negative number. See, the square root of 5 is going to be between 2 and 3. Yeah, I know that because the square root of 4 is 2, right? And the square root of 9 is 3. So therefore, the square root of 5 would have to fall in between that. That tells me that 1 minus square root of 5 is going to be a negative value. And of course, a negative divided by a positive is a negative. You guys already know this stuff. So that means that I cannot use that first value. It's not going to fly. In fact, I could just stop right now because this is going to take me nowhere. It's undefined at this point. So that means we're going to try again with the other version. So now let's use the other value. So that means instead of using the 1 minus square root of 5 divided by 2 for u, we're going to be using the 1 plus square root of 5 divided by 2. And this should equal 5 to the x, like so. And now we'll be taking the natural log. Now, of course, you could use the common log, but I'm lazy, and it's an additional letter. So I'm going to be using the natural log. Yeah. Just taking the easy way out. That's how I roll. You know what I'm saying? Yeah, that's the way Mr. Whitt does things. I'm going to simplify these steps if I can, you see. All right, so it's at this point that we have the natural log of 1 plus the square root of 5 divided by 2. This is going to be equivalent to x times the natural log of 5. And this is using my logarithmic rules, knowing that the exponent on my quantity can come in front as the coefficient. And it's going to be equivalent to that. So in other words, I just brought that exponent down as the coefficient of x. There you go. It's the same thing. It is the same thing. And now solving for x, we're going to divide both sides by the natural log of 5. Oh, yeah. That 5 over here is ugly. Yeah, I'm going to fix it. Yeah, it had to be changed. All right, so the natural log of 5s will cancel out on the right side. Your value for x is the natural log of 1 plus the square root of 5 divided by 2, all being divided by the natural log of 5. And when you plug this into your calculator, the approximation for this, look at my approximation symbols in there, is going to be approximately 298,994 millionths. Yeah, that's a mouthful. So this is your value for x. All right. So in order to solve for y, remember y is equivalent to 5 to the x. So you'll be saying that what is 5 to the 298,994 millionths, and you'll plug that. Oh, you can't even read that, can you? Let's fix this. There's no reason why this is not legible. Let's go ahead and rewrite it. It's 298,994 millionths. You calculate that, you'll then get the approximate answer for y, which is 1 in 618,034 millionths. Yeah. Okay, I'm going to clean this up. I'm going to clean this up for you, and I'll put the result right here. There you go. That is the answer for problem number 1. I promise you, there's not going to be many more problems like this in this video. So we just had to get the ugly out of the way. We're getting the ugly out of the way. All right. You know what I mean? Yeah, I think you do. All right. So there you go. There you go. I'll write this as a point here, and we'll just go ahead and wrap this problem on up. And when I mean wrapping it up, I mean putting it in a red box, because that's what I do. All right. So let's go ahead and red box it. Red boxing it, ladies and gentlemen. That's problem number 1. Let's move on to a better problem, hopefully. Why that last problem had to be so ugly? That was just unnecessary. You know what I'm saying? Gonna come in here, just out the box stressing us out, right? That was just stupid. So let's go ahead and look at problem number 2. Hopefully it can do better than the last. So it's actually looking like it's going to start out similar to the previous problem in that we already have y solved for in both equations, right? So we will once again set the equations equal to each other in order to solve it. So that means I have 2e to the 2x equals e to the x minus 1. And so once again, by setting everything equal to 0, it looks as though this equation will be able to mimic a quadratic equation. So let's go ahead and subtract e to the x to both sides. And if you'll permit, I'm going to go ahead and add 1 to both sides at the same time. At the same time. Okay. All right. At the same time. Appreciate that. Then we're going ahead and rewrite it as 2e to the 2x minus e to the x plus 1 equals 0. And once I have this, you know I'm going to use my substitution. Yes, I will. Let's say that e to the x, let's say it equals m. That means that e to the 2x is going to equal to m squared. Okay, so I'll be able to rewrite the equation as 2m squared minus m plus 1 equals 0. Yeah, there it is. And once again, this is not factorable. Here comes the quadratic equation. We're going to say that a equals 2, that b equals -1, and that c equals 1. All right. Now that I have this, we will go ahead and plug this into the quadratic formula. So here I'll show that m will be equivalent to -b plus or minus the square root of b squared minus 4ac all over 2a. If you need to brush up on the quadratic formula, here's a link right there. You know I got you. I got you. Okay, you're in safe hands. So plugging in our values, we'll have the opposite of -1 plus or minus the square root of -1 squared minus 4 times 2 times 1 all over 2 times 2. From here, we'll go ahead and simplify this. So we'll say that we have the opposite of -1 is +1 plus or minus the square root of 1 minus 8. And this is going to all be over 4. Simplifying our result, we'll have 1 plus or minus the square root of -7 divided by 4. Ladies and gentlemen, this is an imaginary number because you can't take the square root of -7. Well, what does that mean as far as our system is concerned? That means that these two functions will never intersect. We can't even get to a point to where we can plug this value back in to solve for x. Since we can't do that because it's impossible dealing with real numbers, that means that the real function, the graphs of these two functions will never intersect. That means the answer is the null set. It's no solution. These two functions will never intersect, and that is why we're moving on to the next problem. After, of course, I red box it. So because we couldn't find a real value to plug back into our functions, this confirms to us that the two functions will never intersect. It's no solution. It's not happening. Red boxing it. Problem number 3. All right, here we have problem number 3. And with problem number 3, notice that it's set up quite differently than our previous two problems, which is a-okay to me, because if I had one more problem like that ugly stuff before, I'm going to hurt somebody. So problem number 3, we notice that these two equations, we don't already have y solved for in these equations. We don't already have x solved for in these equations. So what I'm seeing is an opportunity to use the elimination method. Oh, if you don't click on that link down there to brush up on the elimination method, because I'm about to use it. Oh, yes, I am. And notice that our y terms are already additive inverses. They just messed up. Did they just mess around and make this problem easy for me? Oh, we're about to kill this problem. Oh, yes, we are. Oh, yes, we are. Because what's going to happen when we combine our y terms? They will cancel. Yes, they will. And so now I end up with 2 to the x plus 4 to the x equals 20. Mind you that these two terms are unlike terms. You cannot add those together directly. All right. So that's why I'm writing those two terms next to one another. Yeah, writing them next to one another. But this is what I can do here. We can show that this equation could be rewritten as 2 to the x plus 2 squared to the x, which equals 20, right? Okay, cool. From here, we'll also show that 2 to the x plus 2 to the x squared equals 20. Yeah. See, I was just using the commutative property, all right, of multiplication there and rewrote it. Pretty slick, huh? Thanks. And now, using substitution, and I'll be using my u again, I'll say that u is equivalent to 2 to the x, and that u squared will be equivalent to 2 to the 2x. And now I can rewrite this equation as u squared plus u minus 20 equals 0. So all I did here was I just simply replaced that 2 to the x with the u substitution that I have there. I rearranged it. I went ahead and subtracted 20 to both sides, guys. All right, you know I did that to set the equation equal to 0. That's where we're at now. But lo and behold, this is factorable. Oh, thank you. Thank you. It's factorable, okay? This problem number 3? Problem number 3 is factorable. Thank the Lord. Thank you. We can use 5 and 4 to factor this. So this gives us u plus 5 times u minus 4. That equals 0 now. And we will be setting both of these factors equal to 0 using the 0 factor property right now. So now, taking each of the factors that we have here and setting it equal to 0, we'll have u plus 5 equals 0. U minus 4 equal to 0. And then we will solve for u in each equation. U equals negative 5. Add 4 to both sides. Over here, we'll have u equals to positive 4. And now, let's go about the business of plugging this in to solve for x. Earlier, we said that u was equivalent to 2 to the x. Let's plug in our values of u so we can find out our value for x, all right? So remember, we're looking for the intersection between these two functions. So plugging in our value of u as negative 5, and we have 2 to the x. Well, this is impossible. There's no way that our base 2 raised to any exponent will equal to a negative 5. That's not possible. It's not possible. Yeah, I know what you're saying right now. You're saying, but Mr. Whitt, how do you know this? Let me go ahead and go through these steps a little bit for you, all right? Let's say I use the natural log of both sides, all right? So I'm saying the natural log of negative 5, this equals to the natural log of 2 to the x. You see where I'm stuck? You see how I'm stuck? The domain for our natural log, or a regular common log for that matter, is greater than 0. I can't take the natural log or a regular log of a negative value. It's not in the domain of the function. That tells me that this is impossible. It ain't happening. All right. So negative 5 is an extraneous solution. You can't use that. You can't use it. Let's go ahead and use this positive 4. All right. Because that positive 4 is where it's at. So let's do that with a wiffle ball bat. Okay. All right. So let's make that happen. We'll have 4 equals 2 to the x. Oh, yeah. Now, notice that my equation here is in base 2. So that 4, yeah, we're going to rewrite the 4 as 2 squared, which equals 2 to the x. Ladies and gentlemen, x equals 2. All right, x equals 2. Here's the rule right here, man. Okay, one of our exponential rules. It's done, son. It's over. X equals 2. So we know what x equals now. All right. It has to equal to 2. And now in order to solve for y, we can plug that into one of the original equations. So I'm looking at the first equation to plug it into. We'll have 2 squared plus 2 to the y must equal 6. Okay. We know that 2 squared is 4, don't we? So 4 plus 2 to the y equals 6. And then from there, well, let's continue. All right, I'll be subtracting 4 to both sides of this equation. Yes, I will. You can't stop me. I mean, you could press pause or stop it in real time. Yeah, I already did it. Notice that I have 2 to the y equals 2. This 2 is to the first power. Using our exponential properties again, y must equal 1. Oh, the problem is over. The x value is 2. The y value is 1. This is the point of intersection for problem number 3, ladies and gentlemen. Thank you for sticking along with me to have a decent problem to do, because the first 2 problems were a pain. Okay? And my side, I thought I had kidney problems for a second there because I was in so much pain from doing problems number 1 and 2. Oh my God. I'm going to red box this. Red boxing it. Yeah, that was fun. Let's go on. Let's move on to problem number 4 now. We have problem number 4. Problem number 4 looks cute. It doesn't give me any anxiety when I look at it. I'm calm. Okay. I am noticing that y is already solved for in both equations. I know I'll be setting these equations equal to one another. Oh, yes. We'll have 3 to the 2x plus 1. This equals 9 to the negative x. Well, on the right side of the equal sign, you can pretty much tell, right, that we can get all of this in a base 3 situation, right? We can do this. We know that 9 is in base 3 would be 3 squared, right? So let's just rewrite it. Let's rewrite it. We're calm. Everything's cool here. All right. We know that 9 is 3 squared. Okay. And it's now raised to the negative x power. That's what we know. And continuing on from here. Oh, and we will continue. Thank you. I'll be multiplying these exponents here using my integers as exponents rules. Thanks. This will be 3 to the 2x plus 1. This equals 3 to the negative 2x. Because our bases are the same. They're identical to one another. That means the exponents must be equivalent as well. That means I can say that 2x plus 1 equals negative 2x. Oh, it didn't have a chance, this problem right here. So we had went through all those obstacles and strains and stresses and trials and whatnot. And the first few problems, that by the time we got to number 4, it didn't have a chance. We squashed it. We are the monster from its nightmare. Oh, yeah. Oh, we came to kick butt. So here we're going to solve for x and line of least resistance. I'm going to go ahead and subtract 2x to both sides. That's what I'll do. Okay. All right. We'll end up with 1 equals negative 4x. We'll then be dividing both sides by negative 4. Look how much fun I am having with you right now doing the math. This is negative 1/4. Okay, we have our value for x. We'll be plugging this into one of the original equations. I'm going to choose the first one. Am I? Am I choosing the? No, I am not choosing the first one. Am I not? No, not. I'm going to choose the second one. The second equation is y equals 9 to the negative x. I'm just thinking this looks easier to plug in our value, so why not use it? So we'll end up with y equals, all right, you couldn't see that for a second. Y equals 9 to the negative 1/4, which means that this is 9 to the 1/4 power. Yeah, 9 to the 1/4 power. That's this result here. So, as an exact answer, okay, our solution is negative 1/4 and 9 to the 1/4 power. There you go. See, I'll be red boxing this. See, I know you're not satisfied. You're never satisfied with me. Red boxing it. Okay, this is the exact answer. I'll put an approximation right here because you're greedy. All right, you're real greedy. You'll be hitting me up in the comments talking about, but Mr. Whitt, what's a decimal representation of the y value, Mr. Whitt? And then I'll be like, but bruh, you told me originally that you couldn't even use a calculator on your test. So why you even worried about that right now? So you worried about the wrong thing, and then it's just all drama now. And see, and I wanted to be your friend, but now I'm thinking, okay, we can't be friends because you stressing me. You see, there's a problem here, clearly. Oh, let's move on, guys. Problem number 5. With problem number 5. Looks like we have a similar situation to problem number 4, which means we're going to kill it. Thank you. In its sleep. Oh, that's the best time. They never see what's coming. So with number 5, I'm setting the equations equal to one another because we already have y solved for. Y has equal to y. Therefore, I have 2 to the 3x plus 4. This equals 4 to the x minus 1. Yes, it does. Yes, it does. I am, first of all, realizing that 4 can be written with a base 2, so I'm going to do that. This will be 2 to the 3x plus 4. This equals to 2 squared raised to the x minus 1 power. Thank you. Okay. Then thinking that I'm going to get my arrows popping. Oh, yes. We have to get our arrows popping here. See if those, the arrows must be popping here. So I'll distribute that 2 as far as the exponents are concerned and end up with 2 to the 2x minus 2. That was fun because I got my arrows popping. Thank you. Since the base 2's are identical, then that means that the exponents must be equivalent to one another, and we set the exponents equal to one another in order to solve for x. That's what's about to happen here once I straighten out the screen a bit. Thank you. Yeah, so we have 3x plus 4. I'm not even going to say anything about what it looked like because that was hideous. Am I violating the rule I just set up? Now we're going to solve for x. Now I'm subtracting 2x to both sides. Are you guys subtracting 2x as well? Or are you being all smart and still trying to skip steps instead of showing your work? Why don't you show your work though? Huh? Why don't you show your work? Why don't you use that documentation that you've been told about? Okay? Document your steps so you can see what went right and you can see what went wrong. Okay. Oh, you don't make no mistakes. So then we're going to subtract 4 to both sides because I do. I make mistakes all the time. Then we'll end up with x equals -6. Pick up the sticks. Okay. So we have a value for x. Yeah, we do. And it doesn't violate any domain restrictions. In fact, we don't have any domain restrictions for this particular problem. Thank you. So that means in order to solve for y, we'll be plugging it in. I think I'm going to plug this into the second equation. Yeah, I could. I think I'm going to plug it into the second equation. Okay, so we'll just do this over here. Second equation. We'll have y equals 4 to the -6 minus 1. Yep. So this gives me y equals 4 to the -7th power, or you can say that it's going to be 1 over 4 to the 7th power if you want to kill that negative exponent. And this will be our solution. Yeah, this will be our solution for this problem, for problem number 5. Absolutely. I'm going to put this result as an ordered pair. We end up with our result, -6 and 1 over 4 to the 7th power. All right. Now, clearly that denominator is going to be a large number. And once again, Mr. Whitt, what's the real answer though? So I'll put that right there. Okay. Have fun with that. Yeah, I'm going to red box this result right here. Red boxing it. Let's move on. Problem number 6. In problem number 6, we have y equals 4 to the 3x. We also have y equals 1/2 raised to the 1 minus x. We will be setting these equations equal to each other. Thank you. This is going to be 4 to the 3x equals the quantity 1/2 raised to the 1 minus x. You can put that in parentheses if you must, if you had to. There it is. And from here, I'm sensing I'll be changing everything to have a base of 2. So from the left side, I'll be rewriting the 4 as 2 squared raised to the 3x. And on the right side, I'll rewrite it as 2 to the -1st power within those parentheses there, raised to the 1 minus x. Okay. And from here, I will be multiplying my exponents using my exponential rules. All right. So this becomes 2 to the 6x equals 2, and I will get my arrows popping. Okay. Thanks. This is -1 plus x. There we go. Yeah. So now that our bases are identical to each other, we'll be setting the exponents equal to one another as well. So we'll have 6x equals -1 plus x. From here, I'll be subtracting x to both sides of the equation, as I do, using the subtraction property of equality. Thanks. Then we have 5x equals -1. Oh, you know the x's are gone. Thanks. Why did you even ask about those? They cancel. Additive inverses. We're going to divide both sides by 5. That's what's happening. And I end up with x equals -1/5. Yeah, we're going to keep the ugly 5, okay? Nope, not going to change it. It's going to be staying the ugly -1/5 that you see right there. All right. Now, in order to solve for y, we can plug this into one of our original equations. So I'll be choosing the first one because it looks easier. All right. So knowing that y equals 4 to the 3x, and then we'll have 4 raised to the 3 times -1/5, which yields 4 to the -3/5. Okay, that's what we have thus far. Well, you're not going to leave a negative exponent most likely. So that means that you'll have a value for y, which equals 1 over 4 to the 3/5 power. Well, of course, that's ugly and all, but that's the right value. So that being the case, I'm going to say that that's the value of y. Yep. Now, once again, you'll be complaining about the decimal representation, which I will be providing for you, which you should have caught on by now, that I'm going to give you the decimal representation of that value because you're greedy. So here's our point. We have -1/5 and this ugly thing here that we'll be calling y. Squeeze it all in there. And of course, we're going to red box it. And this is a 5, by the way. Okay, we didn't want to confuse the children. All right, or scare them, or give them nightmares about math because of that ugly 5 that I had there. But now it's much cooler looking. Yeah, it's cooler looking 5. That is problem number 6. Moving on. On to problem number 7. All right, knocking them out, guys. Knocking them out. We'll begin with problem number 7 by recognizing that it's in a form that the elimination is screaming for. Now, you could use substitution in this, but why would you want to do that to yourself? Why? Why do that to yourself? So I will be using the elimination process. Okay. And I'm going to do that by multiplying the second equation by -1. Oh, it's coming. So I'm going to rewrite this as 3 to the x minus 9 to the y equals 18. The second equation, however, will be -3 to the x minus 3 to the y equals -30. And I will begin killing things. For instance, the first thing I will be destroying are the x terms. Goodbye. And because these are unlike terms, and you should keep that in mind, that we will have a result of -9 to the y minus 3 to the y, which equals -12. That's what we have thus far. Let's go ahead and get everything in view. Great. From here, I despise the negative values that I see. So I'll be dividing everything by -1. It's just as cosmetic. It's just cosmetic, but it soothes my soul. So since I have control and mastery over my soul for now, yeah, I'm getting rid of the negative signs because it's less stressful to look at those. I'll be probably using substitution after I show you that 9 is 3 squared to the y plus 3 to the y equals 12, and then rewriting this equation as 3 to the 2y plus 3 to the y equals 12, we will show that u equals 3 to the y, and that u squared will equal 3 to the 2y. And I'm going to use that substitution to rewrite the equation. It'll be written as u squared plus u equals 12. And if I subtract 12 to both sides here, setting the equation equal to 0, you'll have u squared plus u minus 12 equals 0. And now we have a quadratic equation that is factorable. Thank you, Jesus. We can factor this. This is going to be 4 and 3. So we'll have u plus 4 times u minus 3. This equals to 0. Thank you. And now I'll be setting both of these factors equal to 0 and solving for it. We'll have u plus 4 equals 0. We'll have u minus 3 equals 0. And then I'll be solving for u in each of these equations. Thank you. So I'm subtracting 4 to both sides here. There we go. U equals -4, or we'll be adding 3 to both sides, and so u equals to positive 3. And so in order to solve for y, we know that u is equivalent to 3 to the y, right? So that means that plugging in those values of u, we'll have negative 4 equals 3 to the y, and this is not happening. This is not happening. No, it's not happening because you can't take the log, all right, of a negative value. Okay, so we're going to calm that down. It's not going to be negative 4 that we'll be able to plug back in. It's not happening. So this is an extraneous solution. Nope, bye. Yeah, let's try plugging in 3 now. So we'll have 3 equals 3 to the y. And of course, the 3 on the left side is to the first power. And since our bases are identical, y equals 1, son. Y equals 1. Now that we know that y equals 1, we can plug this into one of the original equations. So plugging in our value of y into one of the original equations, and I'm using the first one, by the way, we'll have 3 to the x minus 9 to the first power. Remember, y equals 1, and this equals 18. Yeah. Well, this simplifies to 3 to the x minus 9 equals 18, and we'll be adding 9 to both sides of the equation. The 9s will cancel out. You'll have 3 to the x equals 27. From here, I can show that 3 to the x is equivalent to 3 to the third power, knowing that 3 cubed is 27, 27 being a perfect cube. And because my bases are identical, oh yeah, we can ignore those altogether. And so x equals 3. Oh yeah. So that's our value of x. So that means that our point of intersection for these two exponential functions is going to be 3, 1. I'm putting a box around this. Sweet. See? That's the way problem number 1 and 2 should have felt. You know what I'm saying? But they were stupid problems. And yes, I'm at fault for making those problems numbers 1 and 2. But you're going to thank me, because look at it like this. If I would have started out with problems like this for problem numbers 1 and 2, you would have assumed that the systems were much more simpler than they really are, that some of them can be dumb, like problems numbers 1 and 2. So by seeing the nastiness at the beginning and then seeing the easier problems later on, see, now you're more well-rounded and prepared to kill your test. You can go ahead and send those comments thanking me for this better grade on your test right now, because you know what's coming. You know you're about to slay that test. Oh, yes, you will. Oh, you're going to make a good grade on that test. Or I'll find you. Oh, I know where you live. We're moving on to problem number 8. Here we go with problem number 8. With problem number 8, we have the equations y equals e to the 4x. We have y equals e to the 2x plus 6. Since y is already solved for, we will be setting these equations equal to one another. We'll have e to the 4x equals e to the 2x plus 6. We'll be using substitution. We can go ahead and set that up now. We'll say that e to the 2x is equal to u, and that u squared must be e to the 4x. Okay, so using our substitution, we'll have u squared equals u plus 6. Then setting the equation equal to 0 by subtracting u to both sides as well as subtracting 6 to both sides. We can rewrite this as, all right, u squared minus u minus 6 equals 0. Yeah, why does that 0 have like that big bang right there? We're going to do a little trimming here. So you know Mr. Whitt could also be a barber. All right, there we go. We just trim that up right there. You see how I trimmed it up? There it is. Look at that. Look at that. Nice clean haircut. There you go. Come back again. This is factorable. Notice that our equation is a quadratic equation. There are 2 factors of 6 that we'll subtract to give us 1, 3, and 2. Factoring this, we'll have u minus 3 times u plus 2 equals 0. If you're having issues still with factoring quadratic trinomials, check out this link right here. I got you. Check that out. You know, don't be stressed. Why be stressed? Go ahead and check that out. Master factoring. Master it. Be good at it. Let's set these factors equal to 0 using the zero factor property. We have u minus 3 equals 0, u plus 2 equals 0, and then solve for each of these equations here. Solve for that. Yes, I know. Plus sign is hideous. Fixing it. Thank you. It's a little better. We're going to then add 3 to both sides in the first equation to give us u equals 3. We'll subtract 2 to both sides in the second equation to give us u equals -2, right? Okay. Well, what are we going to do here? Let's go ahead and see what x may be. Let's see what x may be. I already know that plugging in this -2 is going to give us an extraneous solution. It's not going to happen. Let's not waste time doing that. It's not going to happen, guys. We would end up trying to take the natural log or the log of a negative number. It's not possible. We can only use the 3, okay? Let's say that we learned something today. We can only use this 3. So that means that I have 3 equals e to the 2x. There you go. Let's go ahead and bust out that natural log. There we go. So I have the natural log of e to the 2x. On the right side, the natural log and the e will cancel. Thank you, using your logarithmic properties. So we know that 2x equals the natural log of 3. All right, you see how I turned that around? You see how I turned that around? There we go, there we go. There we go, let's keep things in view. Keep things in view. All right, keep things in view. Thank you. Dividing both sides by 2, though. All right, we find that x is equivalent to the natural log of 3 divided by 2. All right, there we go. And so the natural log of 3 divided by 2 is going to be our value of x. And now we'll plug this into one of the original equations to solve for y. So let's do that. All right, so first I'm going to show that x is equivalent to the natural log of 3 divided by 2. Then I'll be plugging this into, let's say, the first equation. Yeah, are we going with the first equation? We're going with the first equation. We'll have y equals e to the 4x. Well, this is equal to e to the 4 times the natural log of 3 divided by 2. Well, if this is the case, we should have 2 going into 4 twice. And then from here, we can simplify this to show that this is going to be e to the 2 times the natural log of 3. And because of our logarithmic properties, we know that it's e to the natural log of 3 squared. And then from here, I can show that it's e to the natural log of 9. And the e and the natural log will cancel out to give me 9 for the value of y. Y is 9, guys. 9 is y. So that means that my point of intersection, by the way, is going to be the natural log of 3 divided by 2 and 9. Yeah, the natural log of 3 divided by 2 and 9. I'm going to put a red box around this. Red box in it. And, of course, because you're greedy, the approximations are right here, okay, for that x value. All right, but I mean, the exact answer is right there. Then, like I said, you know doggone well you can't use a calculator on your test anyway, so you up there stressing. But Mr. Whitt, what you just quit. Always up there crying. We're on problem number 9. Problem number 9. Come along. Problem number 9. We have y equals 3 to the x. We also have y equals 2 to the x. We're going to set the equations equal to one another, being as though y is already solved for. So that means we have 3 to the x equals 2 to the x. If we go about the business of saying natural log 3 to the x equals to the natural log of 2 to the x, okay, we can then make our exponents coefficients. So this is now x times the natural log of 3. This equals x times the natural log of 2. Then I'll be subtracting x natural log of 2 to both sides of the equal sign. All right. Rewriting our equation, we have x times the natural log of 3 minus x times the natural log of 2 now equals 0. Because these two terms both have my variable x that I need, I will be factoring out the x. So this gives me x times the natural log of 3 minus the natural log of 2, which equals 0. From here, I'll be dividing both sides by the natural log of 3 minus the natural log of 2. Yeah, go ahead and get out of here. Go ahead and get out of my face. So that's gone now, and so x equals 0. X equals 0. How do you like that? I think that's just worked out lovely, because plugging in 0 for x in one of our original equations, let's say the first one, we would have y equals 3 to the 0 power, and 3 to the 0 power is 1. Well, we know this has to be a true statement. If I plug in 0 in for 3 to the x, you'll get 1. If you plug in 0 in for 2 to the 0, you'll get 1. So that's a true statement in both equations. And our solution is going to be 0, 1. And that's it. That was beautiful. I love that problem. Let's do many more problems like this. I mean, not today. I mean, because I only got one more problem for you today. But I'm just saying, in the future, we may have to hook up and do some more of these problems together. Okay? So that's problem number 9. That is problem number 9. And now we're on our final problem. I know. It's been a long time coming. Here it is. Problem number 10. We have 6 to the x minus 1 equals 2 to the x plus 1. That's what we have. Since the y values are equal to one another, we'll go ahead and set those equivalent to one another as 6 to the x minus 1. This equals 2 to the x plus 1. Now we're going to use some of our logarithmic properties here. Hopefully they will help us. I'll have the natural log of 6 to the x minus 1 equals to the natural log of 2 to the x plus 1. And from here, the exponents become coefficients. So I can rewrite this as x minus 1 times the natural log of 6. This equals x plus 1 times the natural log of 2. And then distributing, that's right, getting my arrows popping. I'll have x times the natural log of 6 minus the natural log of 6 equals x times the natural log of 2 plus the natural log of 2. I'm going to put all the terms that have my variable x on one side of the equal sign. So that means I'll be subtracting x times the natural log of 2 to both sides of the equal sign, while simultaneously adding the natural log of 6 to both sides of the equal sign. See, the natural log of 6's will cancel out. The x natural log of 2's will cancel out. And on the left side, I now have x times the natural log of 6 minus x times the natural log of 2, which equals the natural log of 2 plus the natural log of 6. And we will so be moving this on to the next page here. All right, I had to fix that equal sign because it looked like a z. Mr. Whitt, what happened to that z? I know you would have said that. So I fixed the equal sign. Let's move on to the next page here. All right, nasty problem alert. Now we'll be factoring out x on the left side of the equal sign. So factoring out x, I'll have x times the natural log of 6 minus the natural log of 2. This equals the natural log of 2 plus the natural log of 6. Dividing both sides by the natural log of 6 minus the natural log of 2. We'll end up with this value of x here. Yeah, this nasty looking thing right here. Oh yeah, you ugly. You ugly. All right, so there you have it. That's it. That's our value. This is the exact value of x. Okay. Yeah, I know you can do that type of manipulation. Will that help us? I don't know. I don't know that will help you or not. I mean, what, you want to do this? The natural log of 2 times 6, and then the natural log of 6 divided by 2? And so that you would end up with the natural log of 12 divided by the natural log of 3. You want to do that? Okay. Well, you can do that. All right, I guess it is the same thing. It's more compact, huh? Okay, I agree with you. All right, yeah. Let's use this as our value for x. All right. And then in order to solve for y, we would be plugging this into one of our original equations, right? We'll plug this into the second equation. The second equation says that y equals 2 to the x plus 1, right? So plugging this in, we'll have y equals 2 to the natural log of 12 divided by the natural log of 3 plus 1. All this is an exponent right here, y'all. Okay? Yeah, that's ugly. So that means that our solution set then, because this is our value of y, is going to be the natural log of 12 divided by the natural log of 3, comma, 2 to the natural log of 12 divided by the natural log of 3 plus 1. And then red boxing that. Red boxing it. All right. And of course, here's the approximation values for you because that's just how you are. There it is, ladies and gentlemen. And once again, I appreciate you spending time with me, Mr. Whitt, as well as Fort Bend Tutoring, where personalized tutoring is the solution. As always, please rate, comment, and subscribe. And if you're able, please send us a donation, as that will help us bring more free math tutorials to many people around the world through our YouTube channel, Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.